Good morning, everyone. Today we will continue the gas power cycle. So, in previous class, we studied about the basic description of your gas power cycle, that is the Brayton cycle. So, its analysis, its description, and in the last class we studied how you can improve the efficiency of this Brayton cycle using intercooling, regenerative method, and then the reheating. So, three methods we are study and also combination of these three methods. So last class we studied about all those things. Now we will study where exactly this cycle has been used. So that is in a jet propulsion system we are using this cycle. So very brief introduction about this jet propulsion system, that is application of your Brayton cycle. So whenever you talk about propulsion system, the World War II will witness this application of your propulsion system, that is the application of your gas turbine has been evolved during that time. So uh, whatever the engine developed then or whatever the witnessed during the World War II, so that engines are called as jet engine. So in this jet engine, whenever you talk about jet engine, the thrust must be generated. That means opposite force, whatever the from the fuel force it is coming, that opposite force has to be generated. So how we are generating that kind of force, so that you are going to study. So this one is basically based upon your Newton's third law, that is for every action there is equal and opposite reaction. So based upon that, in the jet propulsion system, we have the working fluid which will be accelerated by the system, and reaction to this acceleration produces an equal and opposite thrust. That means we are burning the fuel one side, it will produces the force. If that force is more, then we will get the equal and opposite reaction, so that your object can be lifted and it can be fly in the air. So that is the basic principle they are evolved in the jet propulsion system. So rocket engine also similar principle, but only difference is in the rocket engine we will carry separate oxygen or separate air system, whereas in jet propulsion we are taking the air from the surrounding itself. So that is the basic difference between a jet and a rocket engine. And in the notes we are given some brief history, so for general knowledge. So history about this jet propulsion is that you can go through that one. Now we will come for the principle of this jet propulsion system. Whenever you talk about jet propulsion, it refers to the imparting of your forward motion of the object as a reaction to exit of high velocity gas or liquid stream from the rear end of the object. For example, if we are the object, so in the rear end or backside of that object, if we are burn that fuel, so it will produce also one force, and because of that force there will be equal and opposite reaction force will be there. Because of that opposite force, your object will be lifted up. So that is the basic principle you are involving in this system. So jet propulsion devices are popularly used in a high speed, high altitude aircraft or missile or spacecraft, etc. So you are using this jet propulsion system. So if you want to still simple example how the jet propulsion will work, so we have the inflated balloon will be there. So it is having a small hole or a small gap will be there. If you release that gap, air will comes from the force. So what will happen, air will coming from the force that will allow the equal and opposite reaction to move the balloon upwards or in the opposite direction, hence your balloon can move in the air. So that is the same principle here also you are applying over here. So we will have the high pressure fuel, burning fuel will be that is converted into high velocity. So when you are having high velocity gas which is coming out from your object, it will produce us an equal and opposite thrust, so that your object can flies in the air. So this is the main objective of your jet propulsion system. It is basically depends upon your Newton's second law and third law. So in the Newton's second law, what it states that rate of change of momentum is directly proportional to the force applied. That means you have to create that momentum. So how you are creating that momentum? That is in your gas turbine. So that is the main thing over here. So gas turbine, whatever you are studying, so that is nothing but you have to create that momentum. How you are going to create that momentum? You are creating the momentum by burning the fuel, and you have to pressurize that fuel. So at constant pressure you are adding the fuel, so that it will burn in the gas turbine, it will expand. So pressure will remain constant because it is a constant pressure heat addition. Hence so high pressure your exhaust gas will be there. So from that high pressure exhaust gas we are using the nozzle. So nozzle, it will converts high pressure into high velocity. So high velocity your exhaust gas will come out, and equal and opposite thrust will be produced, and your object will move in the air. So this is how your propulsion system works. So this is about the basic principle of your jet propulsion system. So you have to get the change in the momentum to create that force. So for realizing that momentum change, the high temperature and whatever the pressure gas is there, it should expand in the nozzle. Otherwise, you won't get that moment, because the high pressure, what it is there, it has to be gets converted into high velocity. Then only the momentum will gets or catches that object. So hence, to get that thrust force, the pressure, high pressure and high temperature fuel or exhaust should get converted into high velocity. So for that reason, we are using the nozzle. So conversion nozzle will convert high pressure the fluid into high velocity, which will comes out to the atmosphere, and it will produce us the equal and opposite thrust, or it will give the change of momentum. So this is how the your principle it will behind of your jet propulsion system. Now we will go for the classification of this jet propulsion system. I think you understood this principle behind this propulsion system. So if you have any doubt, you can contact me. Next, we will go for the classification. Whenever we talk about jet propulsion system, it is broadly classified into two types. That is, one is air breathing jet engines, and another one is non-air breathing jet engines. What I mean by air breathing jet engines? Air breathing jet engine means so for combustion we need the air. So if you are taking the air from the surrounding itself or from the atmosphere itself, then that kind of engines are called as air breathing engine. So or non-air breathing means we are carrying separate system for air supply, or especially oxygen supply, because we need that lesser space, or in the spacecraft we don't have a air. So we need some kind of air storage device. That means especially oxygen, we need oxygen cylinders, we need. So that carrying device, so that type of engines are known as non-air breathing engines. So we have separate system for oxygen. So means that the engine doesn't takes the air from the surroundings or atmosphere. So that kind of engines are known as non-air breathing jet engines or rocket engines. So this further classified into several types, that is air breathing engines. So that is continuous type and intermittent airflow type. Continuous means it is continuously, it is sucking the air from atmospheric, whereas in the intermittent, so whenever it is required it is taking from your atmosphere. So again, in the continuous airflow type we have several engines. So in the continuous, again we have the turbojet engines, turbofan engines, turbojet with the afterburners, that is then turboprop will be the, then we have the ramjet or anodized engine. Again, non-air breathing. In the non-air breathing also we have two types, depending upon types of fuel used. either fuel type might be solid type or might be liquid type. So here the fuel is called as propellant rather than the fuel, it is called as propellant. So we have two types, uh, solid propellant and liquid propellant. So depending upon the type of propellant, we have the system or two types of non-air breathing engines, that is liquid propellant non-air breathing engines and solid propellant non-air breathing jet engines. So these are the classification of your uh, jet propulsion system. In brief, we have a diagram over here. So jet propulsion system, that is classified into air breathing jet engines or atmospheric jet engines or non-air breathing jet engines. In the air breathing, again we have two types, continuous, intermittent. In the continuous, again we have the five types: turbojet, turbofan, turbojet with the turboburner, turboprop, and ramjet engines. In the non-air breathing engine, again depending upon type of fuel or propellant, don't we won't call it as fuel, we'll call it as propellant. So liquid propellant and a solid propellant type of rocket engine. So non-air breathing means rocket engine only, because we are having separate kind of air system or oxygen system, it will carry along with the engines. So that type of engines are known as rocket engines or non-air breathing jet engines. Next, we will study all those things, especially turbojet, turbofan, turboprop, and the ramjet. Four types are there, very important. So many times I will ask this type of question. So we will go through this briefly. Then we will go for a rocket system. So that will complete your entire module too. So we will go for turbojet engines. So turbojet, whenever you talk about turbojet, so it consists, diagram shows the diagram of your turbojet. So it consists of a diffuser. So what is the function of a diffuser? That means it is suction of air will take place, and it will pressurize in a small amount because of shape of that diffuser. We will have diffuser, so it will comes in area, cross section will be low, and we have the other shapes, so that it will compress us a little bit in the diffuser itself. After diffuser of this section, it is reaching to the compressor. So compressor, you know that one, whenever you talk about open cycle of your Brayton cycle, so mostly we are, almost most of the time we are using open cycle in the jet engines. So open cycle, the three components of your Brayton cycle, that is compressor, turbine, then combustor. Before turbine we have the combustor. So you have the compressor, then combustor, then we have the turbine. So then exhaust will be leaving to left to the surroundings. So after diffuser, after compressing a small amount of air, then it is going to the compressor. The main function of the compressor, what it has to do, it has to pressurize the air. Remember, it has to pressurize the air. So we have the several rotary blades on the compressor. So your air will passes through this blades. So whenever it is passing through the blades, it will, the compression will take place of the air will take place, and at the end, whatever the required compressor is, the required pressure you want, that much compression will take place in the compressor. So after compressor, we have the fuel inlet. See, this is the fuel inlet. This is the fuel inlet. So what will happen here? It will be, fuel will be injected. So fuel will be injected into high pressure bit hot air. So what will happen? Combustion will take place. So combustion will take place, it will produces the power. So this will be going inside the turbine. Expansion will take place because turbine should drive your compressor over here. So expansion will take place. So it will drives the odd gas, high pressure high temperature gases comes out from this turbine. So this high pressure gas, it is going into the nozzle. So a fifth part will be the nozzle will be there. So that nozzle, what will happen? So high pressure your fuel, as soon as it enters to the nozzle, it converts pressure into velocity. So high pressure. At the inlet we have the high pressure exhaust gas, and at the outlet of the nozzle what will have, the all the pressure will get converted into velocity. That means you are getting that momentum. So momentum you will get, that will convert the required thrust force. So high velocity exhaust it will comes, and it will lift your or it will moves your object inside into the air. Because of high velocity exhaust, it will create the thrust force, opposite force. Thrust means opposite force, so which is opposite to your exhaust gas, and your object will move inside into the air system or atmospheric. So this is how your turbojet will works. So in this case, the fuel air ratio will be around 60 to 1. That is 60% your air for 60 kg. If you are taking in terms of kg, for 60 kg of fuel, 1 kg of air is for 60 kg of air, 1 kg of fuel is enough. So that is the air fuel ratio, meaning of this air fuel ratio. Now we will see the pressure variation, pressure temperature variation. See over here, pressure variation, how it will be. We have the component diffuser. Diffuser, a light pressure increase will be there because of that shape of suction. So light pressure increase will be there in the compressor. After your diffuser we have the compressor. Compressor, it will pressurize for the required level. Then it will comes to the combustion chamber. You are adding the heat by inserting the fuel into the hot air. So what will happen, at constant pressure it is occurring. So you have the constant pressure in the turbine. Because of expansion, your pressure will reduces. Then it is having the pressure, so not that much fully it won't expand in the turbine. So only partly it will expand, so that it has to drive the compressor. So whatever the required power is there, that much it will drive. Then remaining it is expanding, means in the nozzle it will convert that pressure into velocity. See over here we have the velocity. Diffuser, it will reduces in the compressor, slightly increase, almost it should remain constant actually, but actual case, whenever you take about actual case, slight increase in the velocity will get. Here in the combustion chamber again you should have a negligible increase, and turbine slightly increases, and nozzle it will increases in the rapid way. So all the pressure will get converted into velocity. This is how pressure is gets converted into velocity, and velocity will means it will gives the momentum for the object, and it will create the thrust force which will be in the opposite direction. So this is how your velocity, very important, pressure and velocity curve for the turbojet. Next we have the temperature. It will increases, then combustion chamber it will be peak. So then it will keeps on reduces. That's it. Temperature is we don't have much role over here. Next we will go to this TS diagram of this turbojet engine. So what will happen, sir? uh, Here one thing I forgot to tell about a compressor. So due to air reaching the compressor section as a pressure higher than atmospheric, because due to diffuser it is having a slight higher pressure than higher than atmospheric pressure. So this action of partly compressing air by passing through the diffuser is called as ramming effect or ram effect or ram action, because it is having higher pressure than the atmospheric, and there might be a ramming effect or ramming action can take place in the inlet of your compressor. So that is known as, that is denoted by A21. A21 it is represent your ramming effect or a slight pressure rise from the atmospheric because of the diffuser section. Okay, from 1 it is going to 2, that is your isentropic process actually, but actually there won't be a isentropic process. So 1 to 2, that represent your compression process. So it will pressure will be raised, temperature also it will rises for the desired pressure. Then 2 to 3 it represent your combustion at constant pressure. Then 3 to 4 it is the expansion in the turbine, fully won't expand, then partly expands, then it will comes to the your nozzle where it will expand as further so that it will gets converted into high velocity. So this is how your TS diagram will be there for your turbojet engine. So in turbojet engine, air will be coming in the diffuser. So in the diffuser itself, slightly compressed or slightly above the atmospheric, it will be there at the end of diffuser that will be going inside the compressor. Hence, since the pressure is more than the atmospheric, there will be ramming effect at the inlet of the compressor, or ramming action we will call it as. So then it is going inside the your compressor, so where it will compress for the required pressure at the end of compression. So next, it is going to the combustion chamber, fuel will be injected and the combustion will take place, and the combustion product, it is going inside the turbine for the expansion, so that the turbine is which will drive your compression. Turbine is the positive work, this will be the negative work, so this should be drive compressor. Turbine should drive the compressor. Then exhaust, it is going to the nozzle from the turbine where it will convert high pressure exhaust gas into high velocity. Hence, momentum is created. Hence, you will get the thrust force to lift the object in the air. So this is how your turbojet will work. So next, we will go for turbofan. Turbofan. Looking into the diagram, there is not much change. Only the section outside there is will be a change. So the basic procedure will remain same. Inside we have the compressor, diffuser section, compressor. So air is going in the compressor, then combustion will take place, and high pressure, high temperature, it is going to the turbine, expansion will take place, then it is going to the nozzle. So nozzle, it will convert high pressure into high velocity. This is about your turbojet. The only difference, or it is just a modification of your turbojet. So it is the modification. Turbofan is nothing but modification of your turbojet. So we have the fan over here. So what will happen? Add one extra casing outside this engine. So what will happen? This fan drives the air, or it will sucks the air outside this casing. So here air is moving inner casing or and outer casing. So we have the casing space provided. So this high pressure air which will joins exhaust pressure. That means we have to get the more thrust this fan is used. Means one velocity this one velocity this one. That is, along with the exhaust velocity, we have one more velocity, that is the air velocity. So hence the force will be more. Once the force is more, that means the creation of thrust also will be more. So that is the advantage of your turbo fan. So it will be combines both the exhaust pressure as well as air pressure. So that is the difference between your turbojet and turbo fan. So this is how it will work. So total thrust, whatever you are talking about thrust, so that will be created due to two jet streams, one due to this cold air, one and other due to burnt gases or exhaust gases. So we have the fan. So air will be passing through this inner casing and outer casing of the engine or of the system. Then we have the burning gas over here, then we have the cold air over here. So two streams will be there. Thus total effect or total thrust force generated will be more. So whenever you talk about turbofan, bypass ratio is very important. So that is nothing but ratio of flow through the bypass duct. It is called as bypass duct, and flow through the compressor. Flow, whatever the air is flowing through the bypass duct, and whatever the air is flowing through the compressor. So that ratio is known as bypass ratio. Usually it will be around 0.3 to 0.8. So this is the section we are providing. So outside it is in the bypass it is going. So with velocity CA, and it is coming along with velocity CB. So this is the exhaust gas bypasses air. So this is how you will get the this one. So 1 to 2 is the diffuser section, and 2 to 3 is your compressor section. Then 3 to 4 is your combustion. 4 to 5 turbine. 5 to 6 is the exit nozzle. So then 7 to 8 is the exit nozzle for air. This is the exit nozzle for your exhaust gas. Okay, that you remember. So you will be net force will be addition of these two. So hence the thrust will be more compared to that of a turbojet. This is how it will work, turbofan. So next we will have the turboprop engine. So turboprop engine, we will have the propeller over here. Along with the compressor, we will have the propeller. So it is also called as turbo propeller engine, or it is also called as turbo shaft engine, or it is also one more name, it is prop jet engine. So one and the same. So turbo prop, turbo propeller, turbo shaft, and prop jet. So four names are there, all four names that indicate same. So one and the same. So this is slightly different from your turbofan engine. So it uses the thrust to turn a propeller. So there is a thrust force whatever they created, so to turn this propeller. So it consists of, again the basic component will remain same, that is compressor for compressing the inlet air, then combustion chamber, then the turbine, followed by the your exit nozzle. So whatever turbine in the earlier case, it is producing the power only for the compressor, and now we have, along with the compressor, we have the propeller also. So it will rise compressor along with the propeller. Thus, some stage of the turbine gives shaft force for driving compressor, and some stage it produces shaft force for driving the propeller. So it can understood that as if the gas expand, as if the gas expand in the turbine. So gas expansion will take place in the turbine, which drives compressor, and also expand through the power turbine, which drives your propeller through suitable gear reduction boxes. So because same speed it cannot be run, so there will be gear reduction will be there. So gearbox is provided. So this turboprop, whatever you are talking about, this engine are used in small passenger planes, cargo planes, etc. So these are used in over there. So this is how it is going to work. So basic other principle will remain same. Air will be compressed in the compressor, hot gas it will be burned in the combustion chamber when the fuel is sprayed, and then it is going to the turbine, then it is going to the your nozzle, where it will create the thrust force. Because pressure is gets converted into velocity, thrust force will be there, and that will push us your vehicle or object to the air. So this is how it will work. Basic working principle will be there same, and small changes will be there. Based upon small changes, we have different types of engine. And finally we have the ramjet engine. So ramjet engine, so this is simplest of jet engine having no moving parts. So only we have the there in the last three cases we have the moving parts are there, that is rotating blades of the compressor, all those things are there. Then we have the turbine. So here slightly different, it is no moving parts in this ramjet engine, and typically shaped duct open at both ends. So both ends it is in the open position, with the air bearing, air compressed due to forward motion of your engine. So due to forward motion of the engine, air being compressed, and fuel is subsequently added, that is in the combustion chamber fuel is added, and thus produces the high pressure exhaust gas, because fuel is injected at high pressure, because compression already taken place over here, because of the shape whatever it is having and forward motion of your vehicle, and combustion, it will comes to the combustion chamber, and hot air will be in the hot air, your fuel being injected, and so it will be combustion take place, and high pressure high temperature gas which will be exited from the nozzle, which will create your thrust force. So this is how it will works. So here we don't have any kind of moving plates. So instead of that one, we have the diffuser that it will produces the compression effect over here. So mainly three parts. So that is the diffuser, combustion chamber, and the exhaust nozzle. So this diffuser, what it will does, it will have the or two regions of your velocities. That is, one is the supersonic diffuser and one more is the subsonic diffuser. So as the unit moves air at the supersonic velocity, so first it will be there in a supersonic diffuser, so air will be at supersonic velocity, it will enter this diffuser, which decelerated because of the shape, and which will be decelerated to the velocity to the sonic. Then it is further reduced by your subsonic diffuser. So in the subsonic diffuser, still the velocity has been reduced. That means compression has been take place. That means the velocity gets converted into pressure or compression of the your fuel will be take place. Hence, high pressure air will be going inside your combustion chamber, where fuel will be injected and combustion will take place. And combustion temperature is around 2000 degrees centigrade, and it will be expanded in the nozzle. So nozzle, whatever high pressure is there, again it converts back into velocity. So thus we will get the thrust force, and moving forward motion of this object will be imparted. So this is how your ramjet will works, or it is called as ATD. And this ATD name, it is came from one scientist that named as inventor named as Rene Lorin, a French engineer. So that is why it is called a Attard Laurent tube inch. Attard Laurent tube inch. So ramjet are boosted up to the speed of this one is up to the speed of 300 kilometer per hour, and this efficiency of this ramjet engine depends upon a design of diffuser section, because very important, because there is won't be any moving part over here. So design of this diffuser is very important over here. So next we will move on to the advantage and disadvantage of this ramjet. So what are the advantage? As I told, this engine doesn't have any moving parts, and balancing will be very easy, and it yields greater thrust force per unit mass as compared to any other propulsion system, and it is much simpler in construction, light in weight, because there won't be any moving parts, so construction becomes very easy, and components are reduced, and it is lighter in weight, and it will yield much greater thrust per unit frontal area at a supersonic speed, and so best performance can be achieved at 1700 km per hour to 2200 km per hour speed range, and varieties of fuels can be used in this engine, and these are ideal propulsion device for aircraft missiles. What are the disadvantage we can see? So forward motion is very much necessary to realize the ram compression, because in the starting we need some kind of a forward motion, then only that compression is going to start, otherwise it is a bit difficult. So that might be the one disadvantage, and ram pressure ratio increases gradually, that might be a disadvantage during the altitude, and ramjets are unable to work at a low flight speed. So whenever you require a speed to be so then this will be very next. We will go for the principle of rocket propulsion system. So whenever you talk about rocket propulsion system, it is a kind of non-air breathing type of engine, because the it's have its own kind of air system or oxygen fuel system. So it will carries that its own oxidizer for burning of the fuel. So rocket propulsion system is realized by the thrust produced by the combustion product leaving the nozzle. Once again, that part will remain same. That is the major principle of propulsion system will remains the same. That is thrust force created by the combustion product of the gas and through the nozzle. So pressure is gets converted into velocity. So it has a one injection system for fuel and oxidizer, followed by your combustion chamber and exit nozzle. So we have the fuel over here, and one pipeline will be there for fuel, one pipeline for oxidizer. Then it will mix us in the combustion chamber, and it will produce the exhaust gas. Then it is going to your exit nozzle, where it will get the high velocity gases. Got it? So this is how your rocket propulsion system basic things will be there in the rocket propulsion system. Next, classification of rockets propulsion, as already told, according to the propellant mainly, or fuel. Instead of fuel, we are calling propellant. One is the solid propellant rocket engine. One more is the liquid propellant rocket engine. And one more classification based on number of motors. Single stage rocket consists of only one rocket motor, whereas another multi-stage rocket consists of more than one, either two or three. We won't go for more than four. So we will study one basic liquid propellant rocket engine over here. So liquid propellant rocket engine. Before that, what are the requirement of this ideal rocket propellant? Means for fuel requirement actually. So any rocket engine, if you want to use any kind of fuel or a propellant, it should have high heating value. Means energy content of that fuel should be very much high. So hydrogen is one of the best fuel. So but storage is very difficult. If we're going for now cryogenic fluids, then it should have a reliable smooth ignition. Ignition should be very smooth. It should not have any abrupt ignition, and hence the combustion should be a very effective manner. And stability means the fuel should have very stable in nature, either in a chemical way or any other aspect. It should have very stable. It should not react with the as the altitude going high and high, it should not react. So and handling should be very easy. The fuel handling should be very easy, and storing is very important point, because with lesser space it has to store more fuel. That kind of characteristics it should have. Then it should have a low toxicity and a low corrosiveness, and highest very important thing is the highest possible density, because we have the lesser space in the rocket engines. We have to remove the more, means we have to within a small space we want to fill a more number of fuel. So in that case, the density of fuel will matters a lot. So you should have a highest possible density so that it can occupy in a lesser space. So application of rocket, as you know, satellite, spaceships in the research lethal weapons. So these are the where system where you are using this rocket propulsion engine. So now we will go for one liquid propellant rocket engine. So then we will stop this module. So rocket engine, as we told, it will carries its own oxidizer. So here we can see the fuel tank over here. From the fuel tank we have the hydrogen peroxide tank. Then we have the oxidizer. O represent oxidizer. Then we have a steam turbine. Then we have the pumps. Pumps will be there beside steam turbine. From the steam turbine we have the combustion chamber. Then hot gases will pass out from the combustion chamber through the nozzle. N will be nozzle, so nozzle effect will be there after combustion chamber. Nozzle effect that produces the your thrust force. So direction of rocket will be like this. So it will produces the combustion gas. High velocity will be like this, thrust force will be like this. So equal and opposite reaction, we can see the Newton's third law. So this is how your rocket engine will consist of. So your fuel tank, either you may have solid or liquid propellant. So now we will talk about liquid propellant system. So it is a single stage liquid propellant rocket, consists of fuel tank, oxidizer, all those things already I told. So here what will happen, um, liquid fuel is being fed using either pressure feed pump, so pressure feed pump will be there, or uh, any pump. Two types of pump is there, so it is fed from the pump, from the storage tank to the combustion chamber. So next, pressure feed pump, which will be driven by the, so pump has to be negative work, so hence some kind of driving system should be there. So this driving system is done by the steam turbine. So from the steam turbine, pump is driven, and your liquid fuel going into the combustion chamber. Here hydrogen peroxide, where here we will call as the oxidizer, so it will be there. So it will react and it will produce oxygen using this pump once again, and it is going to the combustion chamber. So hydrogen peroxide, whatever is there, that will be converted into oxygen, and that oxygen will mix us with your fuel in the combustion chamber, and ignition will take place in the combustion chamber, and it will produce us the high pressure exhaust gas. So high pressure exhaust gas, it is from the combustion chamber, it is going into the your nozzle. So nozzle, what will does, high pressure, it will convert it into high velocity. So high velocity fuel exhaust gas comes in this direction, and due to high velocity, it will produce this thrust which will be there in the opposite direction. So hence your object will move in the air. So this is how your rocket engine will work. So in the rocket engine we will have the different oxidizer, it will be stored, fuel will be stored, and pump will feed into that fuel and oxidizer into the combustion chamber. Then we will produce the high pressure gases that will be pushes your object to the air. So this is how it will work. So your rocket propulsion system. So this will complete your module 2. So that is Brayton cycle, basic cycle. Afterwards we have the improvement in the efficiency, so intercooler, regenerator, reheat, so then combination. Then we have the basic propulsion system principles. So this many portions are there in your module 2. So all the theory portions are over. Now in the next class we will move on to problematic point. So as per the directions, should write the following questions. So I have divided the questions for different student, different one. So I don't want to everyone should copy all those things. So few members I allocated some question, and I have done the grouping of these questions according to your USA numbers. So note down this one. First we are the Mama Sanin and Kavan. So this is two students and regular students from ME02 to ME09. So these many students will ask to write this question, that is draw the TS, PV and schematic diagram of regenerative Brayton cycle. Just drawing is enough. Drawing should be very neat. That's it. So I don't want to give much burden. So just look into that question and you have to answer. So draw this one and you submit to me. Okay, this many students and regular student from 18ME 13 to 18ME 21. So 8 students, they have to draw THPV diagram, schematic diagram of reheat cycle, reheat Brayton cycle. Then 26 to 33, they have to draw intercooling Brayton cycle. Then 34 to 42, combination of reheat and regeneration. Remember, combination of reheat and regeneration. Then 43 to 51, combination of intercooling and regeneration. Remember. Then remaining student, they have to draw intercooling, reheat and regen, combination of all three. So this is how divided. So whatever with respect to your reversion number, so which question is that, that question you have to answer and you have to submit to me, okay, either through WhatsApp or in a Google Classroom, anywhere you can submit, so no issues. So based upon that submission, your attendance will be considered. So please note this one question. So this will end your module 2. So next class we will finish problems. So hence module 3 will be totally we can cover module 3. Thank you.